may I recognize it as a maximum? I'm going to use the word maximum value. What restriction must be true if I expect that parabola, I have to find the vertex? You say, Professor, but not only is it the vertex, it's the highest point on the graph. Yes. Yeah, the parabola has to open what? Down? And can you take it back to here and tell me when are you guaranteed it's going to open down? Yes.
When A is a negative.
Okay, exactly. That's right. As A is less than 0. And that vertex is going to be your highest point, your maximum point. If, on the other hand, I want a minimum value on that quadratic, we all know now with your help here, it's going to open up. And guys, what restriction on that leading coefficient A must there be for it to open up? Yeah, exactly. So A is greater than 0. That vertex now turns into a minimum. Okay? Now, if after you leave me, you go to USC, UCLA, and they say find the maximum value of, and they give you this. They may not mention vertex. They'll just phrase it as find the maximum. In your head, you'll say, well, no, they really want me to find the vertex. That is the maximum of that quadratic they gave you. So sometimes they will not use the word vertex, so they should the word maximum in. Guys, basically, I think we were doing this yesterday, were we? We did so much yesterday. I think so. Okay. Now, on the handout with the application problems, I did the first one with the stone being tossed in the air, I think. I need one more here to look at where I can apply this. Well, I learned this if you can't apply it. Who has that handout ready for me? Andrew? Guy, go ahead and read the problem number, I guess the first one. Yeah.
SMC is under construction. Workers have 1,200 feet of fencing.
Oh, stop right there. Read that first part to me again.
SMC is under construction.
Are they, oh, stop right, are they really? Anyone who walks around campus, as long as I've been here, that buildings I started out with here when I first started teaching are gone. They're gone. We're going to do a major construction. And I had the opportunity yesterday to walk through the new math complex. Wait till you guys in the spring when you come back for spring semester. Wow. Wait till you see this. Wait till you walk into that new building.
It's open spring.
Spring. But this is the last session of math we'll have here in this building. Special in spring unless something happens. So I had an opportunity to walk through, oh my goodness. They had a planetarium on top of the roof there. Oh, where do you see all this? You'll see it. Now, so we're under construction for sure. Now tell me more.
Workers have 1,200 feet of fencing to enclose a rectangular space that borders Pico Boulevard.
Oh, okay, well, we're on Pico, and they want to enclose a space. Here we go. It looks like this. This ply here. And I'm going to leave that top open for a reason, because I think he's going to tell me something else about it. So we're trying to enclose a space. Construction crew has been assigned to do this. Now, two more.
If no fencing is needed for the side along Pico, what is the largest area that can be?
Yeah, so they're not going to enclose the side here that borders Pico. No fencing needed there. Tell me more.
That's it.
That was it. Now, how much fencing do they have to fence in this?
1,200 feet.
1,200 feet, guys. So what are you going to do? You're going to take 1, 2, 3. They have only 3 sides to fence in. They're going to just take that 1,200 and divide by 3 and say construction crew. 400, 400, 400 should do it. That's 1,200. Isn't it? Okay, now, I might think as a student, why not just divide by 3 and get 400? What's the first question they're asking though, Andrew?
They're asking what the largest outside, what's the largest area that can be?
They want the largest area. How can they take that 1,200 feet of fencing and maneuver it some way, and they want the maximum area they can get here enclosed. So that 400 square business, it may come out to be that. May work and it may not. They want the maximum. So right now I'm gonna say, I don't know at this point. So I'm gonna call this guy's, it's up to you, but I'm gonna call this side X, and Andrew tells me altogether, Professor, for those three sides that you got a fence, you have 1,200 feet. So what would be a good representation to show that last side? Be clever. There you go, take that 1,200, subtract the 2x that we used on the sides. And what's left over, that's the leftover. And by the way, at this point, if I should add up this, and this, I think everyone in class would see the x's canceled. All the x's put together would cancel, and it takes them right back to 1,200. So I'm gonna represent it like this. Now, I'm looking for area. In fact, he's asked me to find the maximum area. First, though, just the area. In fact, I'm gonna write it as A of x in terms of x. That's the area of a rectangle, length times width. Yeah, so I'm gonna multiply it out, show it like this. That's length times width. Better yet, we can write as this, 1,200x subtract 2x squared. Watson, you're not going to make a mistake. Is that a quadratic?
Yes.
We're doing exactly what they were asking me to do. By the way, if I should graph this, or not ask me to graph this quadratic, with this quadratic the parabola, would it open down? In other words, is that A out here negative? It's maybe turned around a little bit. This is the same as this. Is this out front here negative? Which says that parabola, if you should graph it, that parabola is going to open down. If it opens down, are we sure enough talking about a maximum? Is this vertex up here acting as the maximum?
Yeah.
And that's what he just read to us. That's what we're looking for. We like to maximize that area. Now you need to find out what the value of x is that will make that happen. Okay, so I'm looking for the maximum area. My goodness, guys, right back into what we did here yesterday. Now, did you want me to pick up here? I don't want to do it. But would you want to pick up with this and complete the square? Divide everything by -2 and draw the little blanks on each side? I don't want to. You can complete the square. I think Andrew told me earlier, Professor, you need not have a formula to find that vertex. So that vertex, guys, is going to help me out here to find that vertex, which is going to be the max in this case. Let's try x is equal to, he gave me -b over 2a. In this case, it's what? Negative what, 1,200? Over twice, looks like a -2 if I put my numbers in correctly. That's 1,200 divided by 4, I guess. Is that 300? It's positive 300? Ah, clever. We just found this to be 300 feet. That's the x. And over here also. Is that true?
Yes.
I found what x is. I don't have the area yet, but I have the x, the width. Since I'm looking at the sketch here, the length, easily done here. I got 300 and 300. And we know what was 1,200 altogether?
Yeah.
That's going to leave what here, down here for this length?
600.
600 feet. So if I should have walked by the construction crew, and embarrassed myself, and they were talking to me, and said, you teach math, Professor? Yeah, I teach math. We need some help. What do you got? I got 1,200 feet of fencing here. We want to fence in the maximum along Pico. The maximum that we can fence in with 1,200 feet of fencing. And Ramsey stand there and said, well, 400, 400, 400. And they're all laugh at me. It wasn't 400, 400, 400, was it? No. listen, Ramsey, go back and do the math again. It's gonna take on this side 300 feet, 300 feet, and 600 feet if you want the maximum. And that, we just verified through the vertex formula, that is the maximum, is it? Or at least the X and Y and so forth, max on this. Now, I got this done. My students are clever. Can anyone tell me now what is the area of this rectangular piece of ground at this point?
1,800 square feet?
To begin,
1,800 square feet?
is it 1,800 or a little bit larger?
180,000.
I think it's 180, how much?
Thousand.
I heard that 180,000. Is it?
That's another.
300 times 600. Length times width. And I'm hearing, guys, I heard it's a big number, is it? Is it 18,000? Yes or no?
Yes.
No.
I see it's 18 times 10 squared, I'm doing a little math here, 10 to the fourth. 18, or is it 180,000?
180.
Uh-huh. Wow. Square feet. The truth? Now suppose a crew had taken my suggestion, Mr. Math Professor here, and they said, oh, Ramsey, what do you say? I say it's 400, 400, 400. If I'd said that, guys, 400, 400, 400, 400, that area would be 400 times 400? Is that true?
Yeah.
Now, how much is that? 100 and what, 60? And they would laugh as they ran down. You go back to your classroom and do something. They got more. They got the max be 180. I would've gotten 160. They want the max. That's where that negative B over 2A helps me. Yes?
Couldn't you have just known it wasn't 400 either, because it said it was a rectangle, not a square? All the sides would have been the same if you did it.
Good question here. Someone tell me, 400, 400, 400, and Andrew says, Professor, that's a square. And I agree 100% that's a square. Is a square also recognized as a rectangle?
Yes.
Yes. All squares are also rectangles. But the other way around, are all rectangles squares? No. So I embarrass myself. Okay. Guys, that's done. Now, can anyone, before I leave it, tell me, and we did just using a little common sense here, we got the maximum area. Was there anything else to answer besides the maximum area?
No.
Just find the maximum area. We did it. Can anyone tell me another way I could have found that maximum area? Without me recognizing that these are the dimensions. And we multiplied 300 times 600 length times width for the area of the rectangle. We got that way. Can anyone tell me before I close this down, was there another way I could have found that 180,000 besides multiplying length times width? But sometimes you have to do it, so I'm gonna show the other method. If you want to see anything on the board here I could have done besides what I did to find that 180,000.
Maybe we can divide 1,200 by 4.
No. I'm looking for another way to get the 180,000. And we lucked out because we found the length and the width, and all we had to do was multiply the two together. I suppose the student says, no, Professor, I see another way is you should be able to get 180,000. Yes? You tell me, Professor, go in, plug in X with 180,000. Not X with 180,000. X with, what do we find X to be down here? 300? Find A of 300. Area at 300. Let's go back to my area formula right here. Replace those x's by, substitute the x's with 300, which we found earlier. And if I do that, and I do the math correctly, step back and look at it here, it looks like this. Now, I'm not gonna crunch out the numbers. I bet when you crunch these numbers out, I bet you get, what, 180,000? You guys think so? You could have done that. Guys, any concerns here? On the applications of a quadratic or that vertex formula? Anything at all? Looks like it took about 25 minutes just to do that. I got about 10 more minutes to do before I give you guys your 15-minute break. No concerns here. Now, I'll have a big concern when I sit down this weekend if I see some papers that, may not be showing me what I want to see. So if I start seeing that early on, I gotta make sure I sit down with that student or students, and we're gonna have a one-on-one talk. And you gotta keep in mind, we have only 4 more weeks. Get that grade up to where it should be. So don't give me any nonsense on this test tonight. Do the best you can do for that test. Now, the way I'm gonna close down today, part 2. Take a real quick look at it, this. Which I think is the last thing in chapter 7. I'll just briefly get into it. We're moving into chapter 3 on Tuesday. Absolute value of x. But this is f of x equals, we all know the notation. Looks like that. We know the shape. But now everyone should know the shape of an absolute value graph. There's a V-shaped graph. I think I gave it to you though in a piecewise version. I think I may have done it like this. X, if this, negative x, if this. I think I gave you 2 pieces. You have a piecewise function on your test tonight. This one's a simple, just 2 pieces. And if you plot those 2 pieces, which I've done for you before in class, you get that V-shaped graph. So that's sort of like the definition of an absolute value. Now, I am going to sketch right quickly for a reason. Here we go. Let me close out this here shortly. If it is a V-shaped graph, which it is, Professor, yes, under the V-shaped graph. Something like this. And something like this. And so, yes, we have seen this before. The true guy? Now, here's my question. I'm gonna place another line on the grid for a reason. Use blue. I'm gonna place a horizontal line. I'm gonna have it to intersect my red absolute value. Like that. And I'm gonna give you a specific example to help me label this grid graph. Guys, on the side here, let's consider f of x. Let's consider f of x is equal to, let me think of a good one here, why not? Let's see how we're gonna do this. Okay. Absolute value of x. And then I name that blue line for you, just for an example. I would say we're up at 4. So you got the red graph, which is the V-shaped graph, and then I'm putting that horizontal line up at 4, just for an example. Can anyone tell me what the coordinates are of these 2 points, the intersection points? There's an intersection point here. There's an intersection point here. Can anyone give me the coordinates of either one based on what is given up here? Go for it.
Is it 4, 4?
Thank you. Right here's 4, 4.
And negative 4, negative 4.
Love it. All right, now it's -4. Hang on. It is -4.
-4, 4.
There you go. Has to be. You take the absolute value of 4, you get 4, she's telling me. And you take the absolute value of -4, it comes out to be a 4 also. So those are the coordinates. Now what am I doing to lead you into the work on Tuesday we're going to be doing? Now, if you have this, I'd like to have someone, if they could, tell me what's the solution for this. Let's now look at inequality. Absolute value of x is less than 4.
From 0 to 4.
Okay, from 0 to 4, hang on now. I know what you're looking at. You're going from 0 out to here, which is 4, right? I think it's more than that. Let me ask you another question here. With the graph, this translates into when is my red graph below the blue? That's exactly what it means. When is my red graph below, less than, the red horizontal? And whenever that's happening, that's what I'm looking for. Yes?
When you see the blue, do you need a line that's like horizontal above the x-axis?
Well, of course.
So it would be -4 to 4.
Now, beautiful. Let me show you what was just given to me. Red below 4. Well, that would happen here. All this on the red is below the horizontal blue. It's below 4. And you just answered the inequality. Now tell me in interval notation, when does that happen? What's the answer for this? Go for it.
-4 to 4.
That's how it's gonna be. From -4 out to 4. And you've solved the inequality. Now let's try the other way here though. Now I'd like to answer this. When is, I'm in blue again guys. When is the absolute value of x, let's say, greater than or equal to 4? And I'll help you translate this. Now this says, when is my red graph above or on 4?
Minus the
On the blue. When is it above or on? Yes.
Minus infinity to -4 included.
Wow, hang on now. -infinity up to a -4?
Yes,
Included.
And then also 4 included to infinity.
Wow. You guys agree? Now we'll show you what was just given to me. Translate again. The red graph is above or on the blue horizontal. My goodness, we're talking about this piece. Now I'll show you a different color here. We're talking about this piece. This piece. Are the pieces that are above the horizontal line. Is that true? Are those the two pieces sticking out there? Above the blue? That's what I was looking for. And it was given to me for an answer. -infinity professor out to a -4 would describe when this is happening. And on the other end, from 4 through infinity, would describe the other one. Make sense? That's all we're doing. Just looking at absolute values and inequalities and so forth and so on. I'm thinking there's a good way to do this. What's my time here? Am I putting in time for this? Throw this in and get a quick response here. Therefore, if you solve this, you would immediately tell me what's the answer, based on what we've already done here. Thank you. -5 up to 5, something like that. If you solve this, you would quickly, based on what we've already done, tell me, Professor, I don't really have to solve that, I know from that graph over there. The answer is -infinity up to what?
minus
Absolutely. And more.
minus from 7 to
That's exactly what's happening. Therefore, in general here, anytime you see a problem like this, please tell me, and I'm gonna close down with this. In general here, can someone tell me, it's like in the textbook now, if they have this, absolute value of x is less than a, and we're assuming a is gonna be a positive number, something like my graph here. Can anyone tell me what might you say the answer is? If they just throw in now a variable rather than specific numbers, just try to come up with like a formula. What would that look like? Negative a up to a. Now, as I close it down, can anyone tell me, not interval notation, another way to express that you're caught between negative a and a, x is caught, between negative a and a positive a, what's another way to say that and not use interval notation? And sometimes we'll do that rather than interval notation. You say you're going from a negative a to a positive a, what's another way to express that? And not use interval notation. Look at that. You're saying the x is caught between negative a and a positive a. And I want to use those on Tuesday when I see you to finish up that chapter, or section 2.7, I think it is, on absolute value. But at least we had a chance to get a glimpse of what's going on here. Guys, any concerns, questions? No. Now, what is it, 105, close to 105? So we'll give you a 15-minute break. Be back in here at 1:20.